Hello, this is Ms. DB, and today we're going to learn about how to solve equations with variables on both sides. This is from Chapter 2, Section 4 of your textbook. Our objective is to solve equations in one variable that contain variable terms on both sides. In order to do this, we're going to use inverse operations to collect variable terms on one side of the equation. When you do that, you might want to think about moving them, adding or subtracting, so that you have a positive coefficient. And I'll talk about that in a minute and show you the options. This is a nice guide, and I have this on your worksheet as well, that you can print out and use and keep, hang it up next to where you do your math. And this will work for all equations. So no matter how complex I make an equation, and tell you to solve it, you can solve it if you follow these steps. So first, can you use the distributive property? If so, do it. If not, move on to the next step. And even if yes, after you do that, then check this. Are there like terms on one side or the other of the equal sign? If yes, do it. If not, move on. Are there variable terms on both sides of the equal sign? And this is where we're at today. This is the step that we will be adding today. So if there's a variable on both sides, we collect them on one side, and we'll talk about how to do that. And then after you do that, you are going to have a two-step equation, and you will solve the way we've been practicing. Check and see if there's a number added to or subtracted from the variable. If yes, do the opposite. And then is it being divided or multiplied? If so, do the opposite. And then you should always check your number when you're done. So here's an example that has a variable on the left side, we have 7n, and a variable on the right side, we have 5n. You have two ways to collect the variables on one side, as we say. You can either subtract 7n from both sides, and if you do that, you will get 0 here. The n's will be gone, so you'll be left with this minus sign becomes a -2, because this is really plus -2. That -2 has to come down. Do not forget the negative or your answer will be wrong. And then on the right side, we have 5n minus 7n. 5n minus 7n would be minus or -2n, and then we have the plus 6. That's one method, and then we would continue solving. The other method, let me erase this. That's not the eraser. I can't read there we go. Okay. The other method is to subtract 5n from both sides. Now this is what they were saying, hint, if you do it this way, we'll have a positive 2n over here, and a lot of people work with positive numbers better than negative numbers. So then 7n minus 5n is 2n minus 2, the equal sign comes down, these cancel, 5n minus 5n is gone, and then we have the 6. And then we would continue solving the same way we have been. You would add 2 to both sides. We get 2n equals 8. And then the last step would be to divide both sides by 2, and we'll get our solution of 4. And you can check this quite quickly by just taking, you can even do this on scratch paper, putting the 4 back in every time you see an n, and checking what we get on the left side. 7 times 4 is 28. 28 minus 2 is 26. You don't have to worry about your formatting so much when you're checking. And on the other side, we have 20. 4 times 5 is 20, plus 6, which is also 26. So I checked it. It works. N equals 4 is the right answer. So on your worksheet, there's, I think, 5 or 6 problems where you're going to do problems just like that. Here's 4 of them. I put the chain on here so that we can kind of check it as we go what we need to do. So let's do number 3 together. In number 3, let's check. Can we use the distributive property? Well, there's no parentheses, which alert us that there might be a distributive property to work with, so we don't have to do that. So nope, no distributive property, so I'll move on. Are there any like terms on one side or the other of the equation? 8r plus 4, no, they're not like terms. 10 plus 2r, no, they're not like terms. Never combine like terms across the equal sign. That doesn't work. So we can't do that. So we're going to move on to this step here. Are there variable terms on both sides of the equal sign? Because we have an 8r on the left and we have a 2r on the right. So it's a yes. Now, it's not wrong if you subtract 8r from both sides, it's not wrong to subtract 2r. You get to pick which one you prefer. I'm going to go ahead and subtract 2r from both sides for 2 reasons. One, I'll get a positive 6r instead of a negative 6r. And the other reason is because now the variable ends up on the left side, which I kind of like it to look that way. But there's no wrong, it's not wrong to subtract 8r from both sides. So 8r minus 2r is 6r. And if I had subtracted 8r, I'd get the exact same answer. And then I have 6r plus 4 is equal to 10. Now the next step is to do this step down here, which we will have to do. Is there a number being added to or subtracted from the variable? Well, yes, we have plus 4. We have 4 being added to r. So I need to subtract 4 from both sides. And I'm just going to move up here. 6r is left. Plus 4 minus 4 is 0, so I don't have to write that. And then on the right side, I have 10 minus 4 is 6. And then I can move on to this step, which says, is the variable being multiplied or divided by a number? Yes, it's being multiplied by 6. And the opposite is to divide both sides by 6. And 6 divided by 6 is 1. And then my last step is to take my answer, r equals 1, and put it back into my original equation wherever I see an r. So on the right side, I would have the left side, I would have 8 times 1, which is 8, plus 4, or 12. On the other side, on the right side, I would still have the 10 plus, and then I'd have to take 2 times r, but 2 times 1, which is 2, and that's also equal to 12. So it checked. This is indeed the correct answer. All right, now sometimes they get a little bit more complicated, and as we saw in that sequence chain, we might have to use the distributive property first, or we might have to combine like terms. Sometimes we even have to do both of those things. In this example here, there's a lot going on. We have 4 minus 6a plus 4a equals negative 1, and then minus 5 times parentheses 7 minus 2a. There's some distributive property on the right side. On the left side, we have some like terms. Let's do the distributive property first. We're going to take the negative 5 times 7, and then the negative 5 times negative 2a, or minus 2a. And when we do that, we end up with, on the right side, negative 5 times 7 is negative 35, and negative 5 times negative 2a is a plus 10a. So that sign changed to a positive there, a plus. Now we have to look for like terms. So remember that the like terms can only be looked for on one side or the other of the equal sign, or both, but not across the equal sign. So on the left side, we have like terms right here. They're green. Negative 6a plus 4a. The minus sign is part of the 6a. So that negative, this sign here, is going to make this be negative 6a plus 4a. This is wrong if you say this is negative 10a. It's not. It's going to be negative 2a. And on the right side, this negative 1 minus 35, that's going to be negative 36. So we can combine on both sides for the same step, but they don't go across the equal sign. So now we have 4 minus 2a equals negative 36 plus 10a. Now we're to the step that says, all right, you've got a negative 2a on the left and a 10a on the right. We need to get those terms together. We can either add 2a to both sides or subtract 10a from both sides. And again, either one is completely valid. Neither is better than the other necessarily, unless you prefer one or the other better. Now they're moving the number first. I'm not going to do that. I'm going to combine, just like my sequence says, I'm going to put my like terms together first. So that would leave me with 4. I decided to add 2a to both sides. These cancel, and I'll have 4 equals negative 36 plus 12a. Now I have a two-step equation. It has negative 36 being added. I want to undo the negative 36, and the best way to do that is to add 36 to both sides. 4 plus 36 is 40. So I have 40 equals 12 times a And I have to divide both sides by 12. Now, I'm going to get a fraction or a decimal for my answer, which we do get sometimes. Let's see, 4 goes into both of them. 4 goes into 40 10 times. 4 goes into 12 3 times. So I could leave my answer as 10/3, or you could change it to, this ends up being 3.333333, or 3 1/3. Checking fractions, checking decimals is a little trickier, and I probably would just kind of look over my work and make sure that it looks like I did all the steps correctly as a check instead of putting that back in, because that might take me quite a while. This is just them doing the same thing, and their last step, they're going to show that they get the same exact thing I do. All right, here's the problems from your worksheet, and I put the sequence chain so we could check what we needed to do. There is, I think, number 7 on the worksheet, I think is the one that I maybe did for you, and there's a couple more. So this isn't the whole worksheet, but it's a couple of them to look at. Let's look at number 8. We have 5 plus 3 times q minus 4, and then on the other side, 2 times q plus 1. So our first step says check and see if you can do the distributive property. If yes, do it. All right, so I'm going to put my answer up here so that I can have enough room to show my work. So we have 5 plus 3 times q. So you have to multiply the 3 times q, and that's just 3q. And then we have to multiply 3 times negative 4. Or you can write the minus sign and then say 3 times 4. Either way, you'll get a minus 12 here. One of the biggest mistakes students make solving equations is they forget to do the distributive property to the second term. They write 3q minus 4 instead of 3q minus 12. And then we also have to do the distributive property on the right side. So this is equal to 2 times q, which is just 2q, plus 2. 2 times 1 is 2. All right, now we're ready to look for the second step. Can you combine any like terms? And there is like terms on the left side. We have a 5 minus 12. Remember that this minus sign is part of the 12. So we have 5 minus 12, which is negative 7. And if you're not sure about what 5 minus 12 is, if you can't remember the rules for adding and subtracting integers, check it on your calculator. Because if you write down 19 here, or negative 19, or a plus 7 instead of a minus 7, then you're going to get the whole equation wrong, and that would be a bummer. And there's no like terms on the right side, so I'm just rewriting what I have left. Okay, now I'm ready to move on to the step we learned about today, which is, are there variable terms on both sides of the equal sign? We have a 3q on the left, and we have a 2q on the right. Now I'm going to purposely subtract the 3q to show you what can happen and what to do if you get a negative 1q. All right, so now we have negative 7 equals 2q minus 3q. That's negative 1q. And some people might write negative q here. That's fine. Negative 1q is equal to negative q. And I want to look at what to do when you get a negative 1q there. All right, so now we're ready for the next step. Let's see, I'll use blue. Is a number being added to or subtracted from the variable? Well, yes, we have plus 2 added, so we have 2 added to the variable. So I need to do the opposite, which is to subtract 2. So I get negative 9, negative 7 minus 2 is negative 9, equals negative 1q. And some people might think, oh, that's good enough for the answer, but it's not. We need to continue on and do the last step. Is it being multiplied or divided by a number? Yes, it's being multiplied by negative 1. So the opposite of that would be dividing by negative 1. Negative 9 divided by negative 1 is a positive 9. So we get 9 equals q. Now when you get to this point, after you've divided by negative 1 enough times, you'll be like, well, wait, all I have to do is change the signs of both of them, and I'll have 9 equals q. So that's kind of the shortcut. If you have an equal to a negative variable, like negative 1 variable, you can just change both of their signs to find what the variable would be equal to. And then the last step is to go back to the original problem and put the answer in for q and see if we get the same thing on both sides. So don't go into the checking, forcing it to be correct. You want to really check, simplify this side, simplify that side separately. Don't pay attention to what you get on one side. Do them independent and see if you get the same number. So 5 plus 3 times 9 minus 4 is 5. Remember your order of operations here. You don't add the 5 plus 3 together. You do the parentheses first. Please excuse my dear Aunt Sally. There's no exponents, so next we do multiplication. So this would be 5 plus 15, and 5 plus 15 is 20. Okay, that side's done. Now move over to the other side. We have to do the parentheses first. That's 10, so 2 times 10 is 20. Now we look at the two sides and say, yes, they are the same, so then this is my solution to this problem. And you don't have to show your checking on the worksheet, but you should be checking your work, especially on a quiz or test, to make sure that your answer is correct. All right, we are going to move on then to one more type of problem or solution that we sometimes get is called an identity or a contradiction. So an identity is when you get a true statement on both sides of the equal sign. And the answer is infinitely many solutions or all real numbers. You can say either one. You can say infinitely many solutions, or you can say all real numbers. Some equations are always false. These have no solutions, and that's what you write for an answer. Let's look at some examples. Let's say we had the problem 2 plus 1 equals 2 plus 1. If we do the work on the left, we get 3. If we do the work on the right, we get 3. This is always true. Now, if we have an x in our equation, 2 plus x equals 2 plus x, if we go ahead and try solving this, the x's, the variable term, cancels out. When we subtract x from this side, we get just the 2 left. When we subtract x from this side, we have just the 2 left. This is always true. No matter what value you put in for x, it'll be a true statement. So this has infinitely many solutions, or you can just write all real numbers. Any real number that you put in here will make this true. On the other hand, there's some statements, equations, that will never be true. 1 will never equal 1 plus 2. X will never equal x plus 3. When we subtract x from both sides, we get 0 equals 3. That's not true. So we would say no solution on this problem. If you get a false statement, you write no solution. So the way that you do these problems is exactly the same as all of the other ones that we've been working on. You just start solving it. It's when you get to the end that you say, oh, wait a minute, this one's different. So we start by looking to see if there's the distributive property, which there's not, and then we see if there's any like terms to combine on either the left side or the right side. And there's like terms. We have on the left side we have 10 plus 1, and on the right side we have 7x and minus 12x. So we go ahead and we combine those, and we get 10 plus 1 is 11 minus 5x. And then on the right side, 7x minus 12x is minus 5x. So we have 11 minus 5x. Now at this point, you might say, wait, 11 minus 5x, 11 minus 5x, it's the exact same thing on both sides. If you get to that point and you catch it, right now you can write all real numbers. Or you can keep trying. You don't always see that. And you can try adding 5x to both sides. We're going to undo the minus 5x by adding 5x. When I do that, I get 11 equals 11 because these cancel and these cancel. 11 equals 11 is always true. So for an answer, you can either write infinitely many solutions, or you can write all real numbers as your solution. Okay, here's another example. In this one, there is no distributive property, so we'll go ahead and look for our like terms. Let's see, we have 12x and plus x. Now this is a plus 1x. This is 12x plus 1x. On the other side, we also have x's. We have 5x plus 8x. So on the left side, 12x plus 1x is 13x, and then we have the minus 3. On the right side, we have 5x plus 8x is 13x minus 4. So, I'll go ahead and subtract the 13x from both sides, which will cancel it on both sides. You won't have any x's left. and you'll have -3 equals -4. Well, that's never true. So we would write no solution for our answer. There's no x value that will make this true. There's no solution. Here's some of the problems from your worksheet. There's some more on the worksheet. There's some that I solved. Let's look at number 18. That one looks a little bit long. There's no distributive property due. There's no parentheses. So let's look for like terms. We've got a 3x and a -2x on the left side. On the right side, 4x and 10, neither of those are like terms. So we combine 3x and -2x, and we get 1x. And I'm not going to finish this problem because I can see that I am going to be able to solve this and get an answer. So just because these problems are in the section on sometimes you'll get an answer of all real numbers or no solution, this one is one of the examples on this that you will get an answer for. So you'll go ahead and finish solving this. So I'll pick a different one to do. Let's do number 12 instead. So 6y minus 1, those aren't like terms. On the other side, we have 8 minus 9, those are like terms, plus 6y. So 6y minus 1 equals 8 minus 9 is -1, and then we have our plus 6y. So I have a 6y here, so I will subtract 6y from both sides. And when I do that, I'll have no y term left. No variable term will be left. I'll be left with -1, because that sign goes with it, equals -1. This is always true. It's a true statement, so you write all real numbers. Number 13 is super quick. There's no like terms to combine. There's no distributive property. So right away, we can subtract x from both sides. And you can see that that will cancel the x on both sides, and you'll be left with 2 equals 4. And that's never true. That's false. So you write no solution. That's a quick one. Number 14, you'll do the distributive property first, and then you'll either pick all real numbers or no solution, because I can see I'm going to get a 2x on both sides, and that means I'm going to get one of these two possible things. All right, and then your last problem on your worksheet is an application problem that will help you out for when you take geometry. In this one, it tells us that the segment addition postulate tells us that the sum of the parts of a segment will be equal to the whole segment. So it tells us that PQ, the length of PQ, plus the length of QR will be equal to the length of the whole thing. And that makes sense if you have one line broken into two parts. If you add the two parts together, it will equal the whole line. That's all that's saying. So to write an equation for this problem, we're just going to substitute in the different expressions and write an equation. So PQ is, the expression for that is 3n, so that will go here. QR's expression is right here, that's 25. And then our equal sign. And PR's expression is the whole thing. It's 9n minus 5. So we have an equation to solve just like all of the rest of the worksheet. It's an equation with a variable on both sides. So you'll follow your rules, so get your variables together on the same side, and then find out what you get for n. All right, so if you have any questions, please let me know, and have a wonderful day.